In this lesson, we're going to apply what we've learned about the cast rule and the concept of related angles in order to solve some basic trigonometric equations. The first one being sine alpha equals 0.7859, and we were asked to find the values of alpha between 0 and 360 degrees. So we're going to start off by using our calculator to find one possible solution. So if sine alpha is equal to 0.7859, I can use the inverse sine button on my calculator to find one solution to this equation. Typing that into your calculator, ensuring that your calculator is in degree mode, will give you one solution. So I'm going to mark that with a little subscript 1, which is 52 degrees. Now, I'm saying one solution because this equation has more than one solution, because as we've been studying, related angles have the same trig ratios. So any angle related to this one, well, I should say some of the angles related to this one, will have the same trig ratio, the same sine ratio, depending on what quadrant the terminal arm lies in. So if we were to draw ourselves a little sketch, an angle of 52 degrees has its terminal arm in quadrant 1, say right around here. Now looking back to the question, the sine ratio we're looking at is positive. Now remember, the cast rule tells you which ratios are positive in each quadrant. So let's just give ourselves a little reminder here of the cast rule. So remember, sine is positive not only in quadrant 1, but also in quadrant 2. So this equation has another solution in quadrant 2. So if I draw the related angle in quadrant 2, it would have a reference angle here of 52 degrees. And then we could find the value of, the measure, of that angle. So let's make a note here. So sine is also positive. I'm not having much luck with the writing here. Sine is also positive in quadrant 2. So in quadrant 2, a second value for alpha could be found by subtracting 52 degrees from 180 degrees. So a second value would be 128 degrees. So our two possible solutions between 0 and 360 are 52 degrees and 128 degrees. Okay, on to the next example. The next example says if cosine beta equals 0.8192, find the values of beta between 0 and 360 degrees. So we'll take a similar approach. We'll use our calculator to find the first solution. So we know that one solution for beta can be found by finding the inverse cosine of 0.8192. And the calculator will tell you that that is 35 degrees. So let's draw a picture of where that is. 35 degrees would have a terminal arm in quadrant 1. And looking back at our question, the cosine ratio is positive. And remembering from the cast rule, cosine is positive not only in quadrant 1, but also in quadrant 4. So that means another possible solution is in quadrant 4. Right here. So we will say cosine is also positive in quadrant 4. So a second value for beta can be found by subtracting 35 degrees from 360 degrees, giving us an answer of 325 degrees. So therefore, the solutions are 35 degrees and 325 degrees. Moving on, if tan theta equals 1 over root 3, find the values of theta between 0 and 360 degrees. Now this tangent ratio is given in exact form, and so we can use special triangles to solve this one. So using special triangles, we know that one possible value of theta will be tan inverse 1 over root 3, which using our special triangles we know would be 30 degrees. So 30 degrees has a terminal arm in quadrant 1. Okay, and following the similar process to before, look back at the question. The tangent ratio is positive. Using the cast rule, we know that tan is positive not only in quadrant 1, but also in quadrant 3. So we have another solution to this question in quadrant 3, right here. So we will say in quadrant 3, a second value for theta could be found by adding 30 degrees to 180 degrees, because of course the acute reference angle here is 30 degrees. So a second answer would be 210 degrees. Therefore, the solutions are 30 degrees and 210 degrees. And we're going to go through one more example so that I can show you a couple of things that may happen in these solutions when you're working through your homework questions. Okay, so looking at the next one, it says if sine beta equals negative 0.8923, find the values of beta between 0 and 360 degrees. We start this question off the same way. We find our first value of beta by finding sine inverse of negative 0.8923 and typing that into the calculator, we get negative 63 degrees. But we notice that beta has to be between 0 and 360 degrees. So the negative 63 degrees is not going to be part of our solution. We can't use that one. So let's make a note of that. But we know that beta is in between 0 and 360 degrees. So this solution is what we call inadmissible. Now let's draw a picture of where this terminal arm would be located. So an angle of negative 63 degrees would be here in quadrant 4. So what I can do there is I can express this as a positive angle instead by subtracting that from 360 degrees. So we'll say beta is actually 360 degrees minus 63 degrees, which is 297 degrees. So there's one solution. Now to find our second solution, go back to your question and notice that in the question the sine ratio is negative. That's going to help you determine where your other solution is in this question. So the sine ratio is negative. Now think about this. The cast rule tells you where the sine ratio is positive. The cast rule tells you that sine is positive in quadrant 1 and quadrant 2. So from that, we can see that the sine ratio is negative in quadrants 3 and 4. So we have our solution in quadrant 4. But we have a second solution to this question in quadrant 3, right here. So we're going to say sine is also negative in quadrant 3. So a second solution here, I guess technically a third solution, but the second solution that we're going to be able to use in this question will be found by adding 63 degrees to 180 degrees. So our second solution will be 243 degrees, because this angle in quadrant 3 has a reference angle of 63 degrees, because these are related angles. So I'm going to add 180 degrees onto 63 degrees to find the measure of that angle, which will be 243 degrees. So therefore, the solutions are 297 degrees and 243 degrees. And that concludes this lesson.